Yep, sure. Okay. Hi guys. Good morning. Good evening to everyone. And my name is Bharat Kumar, and I'm a PhD researcher, a researcher with IIT Madras, that's in India. And I have about 10 to 12 years of expertise in overall. And for the last 4 years, we are into NLP and it's natural language processing. That's a part of deep learning thing, and where we take up the text data sets and work with it to get some insights. Okay, that's a small brief about me. And welcome to the machine learning and its impacts from the Ismart learning. I would just walk you through on how it impacts the machine learning, the AI, and the data science, how it impacts the career, and what it does exactly in the real world scenario. And we'll talk about the options that you have when choosing the AI as a career, and what kind of job role and how it impacts, and what all the benefits out of it, and what how you should be equipped to sail through this career. Okay. And if you have any queries anywhere on the middle, you can just post it in the chat bot, and I'll just be happy to answer your queries. Okay. I'm just hoping that you are able to listen to me in a very clear and audible way. Okay. In case if you have any difficulties, just ping me in the chat. Okay. Before we start with machine learning, why machine learning and everything, I just want to talk something about AI and what is the boom in this industry and how it is happening actually. Okay. So predominantly, what I would say is, probably you might have heard in a lot of news headlines recently when people started reporting that uh, Alexa was laughing unexpectedly, and there are a lot of news reports led to usual jokes about computers taking over the world. Okay, but there is nothing funny about considering AI as a career field. Just the fact for your understanding, I'm just telling you this: 5 out of 6 Americans use AI services in one form or another in every day, in day-to-day life, in every day, and that's just alone proves that it is a viable career option to choose. Okay, just think like out of 6 people, 5 people are using it. Whether they might be aware, they might not be aware, but they are using AI in one way or the other. Okay, it's not just because it's making headlines. Okay, AI has been a sound career choice for a while because of the growing adoption of the technology across industries and the need for the trained professionals to do jobs created by this growth. Okay, so people, the experts are predicting that AI will create. Guys are able to hear me? It's Can you say yes? Okay. And or you are able to see the screen, right? Why machine learning? Okay, great, 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 great. Okay. Oh, okay, fine. So, the experts predict that AI will create close to 2.5 to 3 million jobs by 2020. Okay, it is just forecasted, but this technology will wipe out, it's not going to wipe out any number of jobs. The one thing is like it will create more jobs. In addition to that, AI also offers many unique and viable career options. It's been adopted in almost every single industry. You name it, you have AI in it. Okay, so from entertainment to transportation, and from medical healthcare, and till defense, you have a huge need for the qualified skilled professionals. Okay, probably you might be wondering just what AI is all about. Okay, let's make it very simple. AI is how we make intelligent machines. Okay, it's you cannot compare with a Terminator movie or with a Matrix. That's very far advanced, and we are not yet to reach that stage. Okay, it's just a software. Please understand, the machine learning or the deep learning part is just a software that learns similar to how humans learn. Okay, it's just mimicking human intelligence, human learning, how we learn, how we think. Okay, yes, yesterday I had this and I have to do this right now, so I'm learning from my past experience. So we are making sure that machine should learn in such a way that is going to mimic our human learning part. Okay, and so that it can take over. Please understand, it's not going to be any kind of physical learning ability. It is just our mental learning ability, how we think, how it's, you can just imagine that how our brain is working, okay, and how it gathers intelligence, how it learns from the past experience and everything. Okay, and machine learning is a subset of AI. Probably, oh, in the media or anywhere, you have to understand that people who write about it, they'll not have a clear picture what is deep learning, what is data science, and what is machine learning, and what is AI. Okay, and please understand, the machine learning is a subset of AI, and deep learning is a subset of machine learning. Okay, and if you just imagine as a Venn diagram, the data science part will touch AI and machine learning, and it will not touch that much into deep learning. Okay, so sometimes when describing AI, we are actually describing the machine learning, which is a process by which the AI learns by itself. Okay, so it has a widespread with machine learning, you have a widespread usage. The algorithms that you use to set a training data, we'll talk about what is training data and all these terminologies as well. Okay, so we are trying to enable computers or the systems to learn to do something that they are not programmed to do. In a traditional software engineer, just think that you are a Java developer and you have a use case. What you do is, like, you code, you get an output, and you explicitly tell the computer, please do this step by step. That's your input, and you get an output, and you just rectify your errors and you get a clean code. That's the regular programming structure. But here we are not going to explicitly tell the computer what has to be done. You are going to give set of examples to it. I'm going to give some examples. Please learn it by yourself. That's how I learned. I learned from my past experience. You learn it by yourself. You understand what is going to be there and come up with a kind of a prediction. If the prediction is wrong, I'm there to help you out in correction. Okay. Once that has been done, whatever new data you have your past experience. You have learned from something and you have predicted something. Please use that expertise. Please use that expertise in such a way that humans do. Okay, and AI has widespread benefits. Both the people, individuals, and the companies benefit from AI. And a lot of consumers use AI on a daily basis, and probably some will understand that it's an AI and machine learning, some will not understand, but consumers are using AI on a daily basis to find their destination using a navigational GPS, ride sharing apps, smart home devices, personal assistants, streaming services. You have a lot. You switch on your TV, yeah, you are into AI. So businesses, also the corporates and the business also use AI in various ways. Okay, just for an example, to assess the risk, to define an opportunity, how to cut my cost or expenditure, how to boost my research and innovation industry. So it's something like it's very vast. Actually, I would say, like, AI is a vast ocean. You can do even 10 to 20 PhDs in your career. It's that big. So the thing is, like, AI is rapidly evolving, which is one reason why a career in AI offers so much potential. If you just go to Indeed before 5 years, the top job was, a kind of a JavaScript developer, C++, C Sharp, and everything. It's no more there. Okay, as the technology evolves, everything has got changed, and the scope of the jobs is tremendously improved. Okay, and just for an example, if you just ask me, Indeed, that there is a lot of reports from McKinsey, from Gartner. Uh, every organizations have invested approximately $40 billion in AI technology in the year of 2016 to 17. This is mainly a part of investment went into research and development, and the 10%, right now it is almost 40 to 50% trying towards the implementation of AI technologies in improving the operations, the boosting engagements. You take sales, you take marketing, you take operations, you take development. In any industry, they'll have the structure from the HR till the operations. They are trying to implement AI technologies towards the improvement and the better understanding of their business. Data, we call it as you have to understand your data, because your data is a real thing that will speak truth, that will give you predictive analysis, and that will speed up the intervention process and solve any issues in the real time. You have to solve something in the real time, so you better learn about your data, which you have generated. It's your company, and that has generated this much amount of data. So you have to understand that it should work well. And there is no study stating that, like, yeah, I have collected my 3 years of record and I have do a prediction and that prediction was wrong. No, it's usually the accuracy was close to 95 to 98%. It's not an assumption, guys. It's based on your own real data. You are going to literally you are going to torture the data to get the insights from. Okay, that's how it works. So there are a lot of subsets of machine learning as well. One is the deep learning part, which is neural networks, which is an kind of an integral for teaching computers to think. You are making the computers to think and learn by any kind of any information that you provide, similar to how we humans learn. Okay, you always take into consideration with the neural networks, you are going to teach something, teach your computer to recognize something, to predict something, because you got some past data. That's what we call it as a training data. Okay, let me give you a simple example for you to understand how this entire the machine learning works. Just for an example, I'm just giving you a kind of a raw example which everyone does it in their workplace. Okay, see, the first thing is the main objective of the machine learning is to teach machines how to carry out tasks by themselves. Please understand this. I'm not going to do anything kind of robust kind of thing to come with some innovative or anything. It's simple. I'm going to teach my computer, please learn it by yourself. I have the data, I have the past data, I'll give you the data, please learn it by yourself. It's how. The only thing is which we cannot do is, just for an example, think about an Excel sheet that has 50,000 rows with 60,000 columns. It's not possible for a human being to learn all the dimensions of 60,000 columns and 70,000 features or whatsoever. That's really not possible for us. But yes, since you have got a lot of computational power, a lot of data here right now, you can do that. And please understand, the amount of data that's been created in the world is going to touch 40 zettabytes. 1 zettabyte is roughly 1 trillion gigabytes. This kind of data has been generated just in the last 3 years alone. In the last 5,000 years of human history, I would say 90% of the data has been generated just in the last 3 years. So we have to be very happy that we are probably living in the most defining period of the human history. Okay, probably before 20 years we would have crossed this stage. We will not have access to machine learning or deep learning because our computational power is less. We don't have data to do any machine learning or AI. It was all in kind of a secret labs where the defense force and all this will be taking place. Right now, you have good computational power. You have all the GPU cards and everything comes in the commercial lab, and you have a lot of data. Everyone creates data. Yeah, everyone creates data. But what is the use of taking the data? Just for your example, if a flight travels from say from New York to Washington, okay, just one way. Please understand, it creates not less than 1 TB of data, 1 terabyte of data. And what am I going to do with the data? Yeah, it's no use. I'm just creating the data. I'm just storing on a cloud or a server. And right now, yeah, I can take data scientists, help, and they will create and predict what I can do from the data. They will create it. They will come with a prediction. Yeah, you can reduce your altitude, you can increase your speed, you can reduce your cost, and you can do a ticketing, a price reviews and everything. So over the period of time, what happens is that particular flight which is creating 1 TB of data per flight, after 30 or 40 days, it will create loads and loads of tons and tons of GBs of data. With the data, I'll have a lot of predictions. I'll have a lot of insights, to be frank. Okay, I can use that insights in my business needs to create more business, to achieve accuracy, and also to enhance my operational security as well. So there are a lot of advantages. I'm just giving you one option. You have a lot of options here. Okay, so the period which we are living is a most defining period of the human history, and the period when computing moved from large mainframes to PCs to cloud. Okay, so but what makes it defining is not just what has happened, but it's just started. It's just coming our way, and years to come, probably in the next 5 to 10 years. It will take at least 10 to 15 years to get stabilized, because the amount of data that we have, uh, say about 100, 90 to 95% is unstructured. Please remember, it is unstructured. And just think about a WhatsApp chat that you just download. When you just download and send it to your email, it's not structured, right? It's completely, jaggled and mingled around, and you have to structure it. Just think about that. Every data that we create is not a structured one. So we have to structure the data first, and then we have to get insights from that. And just 5% of the data is structured right now. The 95% of the data that we have it in our servers and cloud and everything is completely unstructured. And there lies data science, machine learning, and artificial intelligence and deep learning comes into the picture. Okay. So let us assume that you are checking your mails on an everyday morning, okay, on your PC. You perform on a daily basis. Probably you would be moving the emails around so that only those emails belonging to a particular topic in the same folder. And after some time, if you do it on a daily basis, just think that you're logging onto your email every day at 8 a.m. in the morning, and you have at least 40 to 50 emails, and out of which 20 to 30 are not relevant to a particular topic, and you have about 4 to 5 folders. It takes 10 to 15 minutes on a daily basis to allocate them on a specific folder. Okay, so after some time you feel bored and thinking of automating this entire thing, because you know what has to be done. So you have all the examples with you. So what happens is, one way would be start analyzing your brain and writing down all the rules your brain would process. Yeah, this is an email that is marked as a spam, and this is an email which is not official, and this is something which goes right on my work folder. So what happens is, this will quite be very always imperfect. Okay, while you might, as a human being, we are prone to errors, and we will miss some rules, and probably at sometimes we will over specify the rules as well. Okay, so a better and more future proof way to automate this processing is by choosing a set of email meta information. Please understand, data and metadata. Data is something like you're having some characteristic phenomenon which is measurable, and if you have some little bit more information of the data that you have, is called metadata or meta information. So you have an email, I have some meta information as well, because my email has a subject, it has a body, it has a sender's name, email address, and everything. That's my meta information. And I'm just going to let an algorithm come up with the best rule set. Okay, the pairs would be my training data, which I have got lots of emails, resulting in a rule set, because I have my rules to set, and that rule set is called a model. Okay, this terminology is used in machine learning, and this model, which I have come up from my previous past experience, could then be applied to future emails that I have never seen it. I'm not sure that what kind of email that I'm going to receive it tomorrow, but I have got a lot of experience in my previous emails, and I have built a model. Okay, this is a machine learning in a simplest form. Please understand that I have got a lot of emails. I have just got, that's my training data, and the resulting rule set, that's called my model, because I know that which email should go in which folder. So I have created the rules, and that's my model, and that could be applied to any of my future emails that I have never seen or I'm not able to see. Okay, so this is the machine learning in the simplest form. Yeah, of course, it's not just, it's just referred to data mining or predictive analysis. You have a lot, but this is the base of it. Okay, so what happens is, to understand everything, you have to understand math, the math is the is a bedrock, or I would say it's, yeah, to understand, it's a rock solid technique by understanding math. If you love math, yes, AI is a part of it. If not, I'm not saying it's not going to be very difficult. You're not going to learn math in a kind of a graduate level. It's just a high school math. The statistics, you can consider a diamond, okay, the four sides. So the top would be statistics, and this corner would be probability, and one side would be calculus, and the other side would be linear algebra. Okay, so what we do is like we learn everything, because computers doesn't understand text data or anything. It just understands zeros and ones. So I have a business statement. I have to take all the data set. I have to interpret into math and give it to the computer in the forms of numbers, and that gets converted into zeros and ones for its learning. And when I'm getting the output, yes, I have to go ahead and decode it in such a way that I as a human can understand. That's the reason that we use specific programming languages like Python, Scala, Java, and Julia. Okay, so please understand those basic terminologies. And what is the purpose of me doing here? The purpose is for us as a human to get insights into the data. Please trust me. Every day, the screen is stuck. Okay, I didn't move my screen yet. Okay, I'm just giving. I'll just run through them. Thanks, Anu. Okay, so what happens is, probably the process, the entire process of learning is, as you read more and more, you learn more and more successful applications of machine learning. You will understand that, the statistics, the probability is a common field of machine learning experts. Okay, the basic line will be math. Okay, I would say, the entire business model is being written in linear algebra, optimized in calculus, and understand in probability. That is what machine learning and AI is all about. Because I have data which is numbers, it could be images, it could be video, it could be an audio, it could be anything. But how am I going to make sure that my PC is going to learn? It doesn't reads anything apart from zeros and ones. Definitely I have to take it through the math. I cannot go ahead and read everything as a human being and understand it first. That will take ages, man. Please understand that. So you have to understand math, and you have to have a programming concept. Then when we come to the algorithms, yeah, that would be perfect. And you can, once you're strong in math and programming languages like Python is really easy to learn, and it's been preferred language. Even though you are a Java developer, or any other language, we literally prefer Python for various reasons, for the libraries, for the packages, and everything. Okay, just to give a small overview, just if I want to say hello world, okay, in Java, it would take 6 to 7 lines. In any other programming languages, it would take 4 to 5 lines. And in Python, it's just one single line. It's a very easy syntax and semantics. My goal and approach is to get insights from the data, and I'm not a programmer. I'm not here to do any web development, or I'm not a software engineer. Please understand that we are not software engineers. We are data scientists. Our main objective is to get insights from the data. The data could be of any form, but I have to get an insight from the data. That's my past experience. My past experience have got loads and loads and tons of GBs of data. My objective is to get, torture, analyze, manage, and process the data, and not into coding. So I have to just use coding as a kind of, an interaction towards my system. So that language should be very easy, and it should be readable. It should be high level programming. That's the reason we always go with Python, because you have a lot of work, guys. So you have a lot of work in math, algorithms, managing a data set, managing GPUs, cloud, and everything. So we don't have to again, bang our head with a programming language. So let's make it very easy. Our job should be very easy. Okay. So what happens is, let's, probably I'm just assuming that, now you have understand what is the machine learning is all about, and why people use it. Do you have any kind of queries at this point of time before I proceed further? Uh, can you just ping me in the chat? Is it fine? Shall I go ahead? Guys, are you able to hear me? Is it fine? Shall I proceed? Okay. So, how about scalar or data munging and wrangling just like R? When it comes to deep neural networks, when you use TensorFlow, PyTorch, and all the frameworks, what happens is all these frameworks have been designed in such a way that it is Pythonic in nature. It gels good with Python rather with any other programming language. That's one thing, okay? And I would say at sometimes we are forced to use Python just because our deep learning frameworks are Pythonic in nature, or it just supports Python. That's one reason. The second reason is Scala. On the other point of view, the IDEs that we use for Scala are like the Java, Eclipse, and everything. Those IDEs are not compatible with the machine learning libraries, packages, and modules most of the time. Either you have to do a kind of an API call and pull it and add it, and you have to upgrade every time. But in Python, it's not so. You have something called Anaconda, Canopy, and everything. Yeah, that takes care of everything. So that's one thing I always go with Python, because it makes my work easier, because I have a lot of work already with my data. So I don't want to again fight with my libraries modules for a programming language. That's one thing. Another thing is like most of the frameworks that is been coming up nowadays are by default are being written in Python itself, to be frank. Okay, most of the frameworks are written in Python itself, and it supports Python by default, and they have inbuilt capabilities for Python version 3. 3 is what we use. We don't use 2. That is for the gamers. Okay, so RH, is it okay? I have just given you an overview. Okay, great. Okay, so now let's understand, let's get a little bit deep into how this entire thing works. What's this? So people call it as, people always say it as, it's a kind of a black box. It's not a black box, guys. It's not a black box. Deep learning is not a black box, because everything has interpretability, everything has an explainability. You can interpret the results, you can understand what is what. Okay, the only thing is like you have to understand math, you have to understand Python, you have to understand the algorithms that you use, and you have to understand your data that you have. Yeah, if you have this, yes, that is nothing called it's a black box and I cannot understand anything out of it. No, it's not like that, because it's humans. We have designed this. It's not something like it's something from somewhere. And please don't think that it's is going to overtake the humans or anything. It's not. No way it can overtake human capability. Okay, so that will take at least another 100 to 150 years to do this. So, but that's way off. You cannot imagine that to happen any point of time. So we always talk about machine learning algorithm and algorithm and algorithm. What's an algorithm? What's a model is all about? Okay, so I'm going to explicitly tell, I have to make a calculation. Even at the calculator that you have in your system has a operating system, has a programming language at the back. So I'm just writing a calculator application. I'm going to tell 2 plus 3 should be 5. I'm explicitly telling that. Okay, so it's just a logic that I'm teaching the system, and you can compare that logic with the algorithms that you have. With all the data that I have, I should tell the computer, you have to do this from the data. You have to understand this from the data. I would say, even if you give me any big data set, you can even finish the coding just in 10 to 15 lines in Python. Very simple coding structure, 10 to 15 lines. You just have to load the data set that's in your PC. You have to just train it, you test it, you validate it. That's it. It's just 5 to 6 steps, and probably you might take 15 to 16 lines, at times 20 lines max. Okay, So that usability is there with Python when compared with other languages. So can you just move to the next slide, please? If you okay, 1 minute, guys. Okay, so here I'm just telling the what the computer has to do. I have .py files, I have Java files, I have JavaScript files. You have nearly 250 programming languages, and please understand that before 5 or 6 years, Python was not even in the list. If you just type, in the year of 2006 or 5 or even 8, if you say top 10 programming languages in the world, Python was not even in the list, and now please trust me, it's standing on second or third. uh, Probably over the period of time it will become first. The reason behind us wide adoption of uh, Python for data science, machine learning, and AI, because these three have predominantly is topping Indeed, Monster, Naukri, or any job portals. It's topping that. And when you say that you have to have a machine learning, you want to have a machine learning engineer, by default they'll ask for Python. R cannot be used for neural networks, and for various other reasons, we don't go with R. So preferred language is always with Python. And why would an employer choose someone who writes 300 lines of codes in Java rather than writing just 50 lines code in Python? It saves time, and that's it's a dynamic language. You write something, you get an error, you rectify, you go off. But it's not like Java is something totally static. You have to write all the 300 lines of code, execute it, compile it, save it. It's heck a lot of work to do. We are not here to do any programming. Just make it very clear. We are not a programmer, we are not architects, we are not software engineers as well. We are scientists. We are going to build something which the world has never ever seen. That's my real data set. No one has got that insight from this data set, and I'm the first person who is going to get that insights in this real world. And I'm going to invent or discover something which is very new. That's why you get a title as a scientist or a researcher. Okay, that's one thing. So that's the logic here. So please understand, what a program is and what it does and what the logic and everything. So you need a program, right? That program you can just compare with the algorithm. You have my data set. I understand what is what. Okay, so I'll give you an example of a simple algorithm to print numbers. Okay, it's just kind of a flow chart that I'm just sharing with you. Probably you might have done this in your school days. I'm just assuming that you have done it in your school days. So you are just starting a program. You initialize it with a 0, and if I want to print numbers from 1 to 10, I have to add up or increment one by one. So 1, then 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. So I have to increment each and every number by 1. Okay, so if it reaches, because my objective is to print numbers from 1 to 20. So if so any numbers that I get less than 20, it should be S, and if it is greater than 20, it is end. Please understand, there is a logic behind it. The logic is to get the numbers only between 1 to 10. Well, I'm sorry, 1 to 20. I should not cross 20. At the same time, I should get everything between 1 to 20. So this is my logic. My logic is very simple. I have to get the numbers between 1 to 20. I should not go x greater than 20. If my x is greater than 20, I should end it. I should just disconnect it. So I'm giving some set of rules or regulations. This is what my rule is. Please understand my rule set. This is the rule that has been created. That rule, you can name it as algorithm, that you can name it as model, that you can name it as in whatever ML terminologies that you want. That's what the whole objective is. Okay, so hope you are getting in the glitch of it. I'm just understanding that it's all just the basics, because I have to make sure that you have to understand the basics first, so that it will make you a real solid hero. Okay. Okay, this is the, I would say this one slide will give you everything about understanding of machine learning. Just compare it with a normal programming language. You have a system, you are writing codes, that's your input, and that side it just process in your system, which is in the middle, and the output will be your end answer. 1 to 10 I have to print. The next thing, you write programs and you get an output between 1 to 10. But here what happens is my input itself is an answer. I'm giving answers to the system. See, this is all the answers which I have got last year. This is all the answers that I have got. Just imagine that you are in a sales company. Okay, let me give you an example that will make up much understanding. So you are doing something called, you want to increase your sales. So you have your sales data last year. You know what kind of sales that you have made in the month of Jan, Feb, for quarter by quarter or month on month, week on week, day by day. You have your records for the last year. I'm giving the data to my algorithm. See, this is what I have done in 2018. Can you just predict based on this how will my sales will be in 2019, so that I'll get some insights in which month I'm going down and which month I'm going skyrocket high, so that I can plan myself in such a way that I'm always on the side of profit and not I'm going on a loss. I'm giving you examples of 2018. Please learn it from there. So that's how you give answers. You are giving answers to the system and making it to understand and coming back with the prediction. Guys, are you able to understand that? I think like you can ping in the chat as well. So if you have any queries, please do ping me in the chat bot. And if you're not understanding, okay, fine, great. So this is what it is. Okay, so you are making computers to learn and act like humans without being, please understand that line, without being explicitly programmed. Please understand that if you don't have the machine learning data or your GPU computational powers, just imagine I have 50,000 rows and 60,000 columns of data of my previous sales. If I want to write programs, trust me, it will take 1 million lines of codes. And by the time you write 1 million codes, it will end up with 2 or 3 years. So there is no possibility of doing any predictions. Just because of the data availability and the capacity of the GPUs and the computational power, we are able to do machine learning today. Okay, that's one among the reason, and we are not going to explicitly tell anything to the computer. Do this, do that, do that. No, it's not like that. I'm giving you the data. Please learn it by yourself. That's what I have learned in my, as a human, I have learned. That's what it is. Okay. So, and one more thing is like you have 3 types of AI. Please understand this. One is artificial narrow intelligence. Another one is artificial general intelligence. And the one is artificial super intelligence. We are in the era of artificial narrow intelligence, which means that I'm going to design a system which can do just one job at a time. If I'm developing a system which can play chess, okay, kind of a deep blue, okay, play chess, it can play only chess. It cannot play carom or any other game that you want to play. You cannot ask the system which plays Jeopardy. Okay, probably you might have heard about the Jeopardy show in US. So Jeopardy, I have a system called X which plays Jeopardy, and that can't play chess. And the one which plays chess cannot play Go. Okay, just like which actually played with Lee Sedol, the top Go player, and it won. So these systems are narrow in nature. It's not like human beings. Yeah, as a human being, I can play snooker. I can play chess. I can play blackjack. I can play a lot. I'm a human. But yeah, the systems are not yet ready to make artificial general intelligence. Please understand that. Right now, whatever systems we make, it's just going to do only one task at a time, and that task will be very specific in nature. Okay, please understand that. You cannot make that particular system, that particular algorithm, or anything to make a different task, because it does not learn. So we are in the era of completing the artificial narrow intelligence and move to artificial general intelligence. I belong to a lab called CCBR, Center for Computational Brain Research. So we guys, what we do is like we are decoding the human brain. Please understand, no one knows how the human brain works till date. Okay, and the reason behind is the most complicated, very hard device to understand in this world is a human brain. It got I don't want to speak about the brain much, but we are trying to decode the brain first, understand how the brain works, and then take all the bits and pieces and take it into the neural networks. One day then I can make a system which can have lot of capabilities. It can do calculations, it can do this, it can play, it can also teach my kids, it can also entertain me or by showing some videos or anything. So that applicability is not there. They are going ahead and developing it right now. It will take ages, man. Okay. And talking about artificial super intelligence, there was a man, I think it's Andrew or Ian Goodfellow. They are topmost researchers. They stated like, by the time you imagine about artificial super intelligence, you need to understand that Mars and Jupiter will be overpopulated with humans. When there is an era where the other planets will be filled with human population, then you can think about artificial super intelligence. You can compare that with the Terminator movie that you have seen. You cannot build such a kind of machine. It's always in the sci-fi. Yeah, that's period. You cannot, that will take, to my knowledge, people say that it will take 250 to 300 years. I'm not sure you cannot even reach in 250 years. It will take a vast time. Now the intention is we have completed the narrow intelligence. We are just moving step to the general intelligence where I have to build a system which has a human capability of doing various things. That's it. Okay. So this is the overview of the entire thing. Now, this is the process. It's just an overview of it's 7-step process, or even at times you can call it as 8-step or 9. It's a workflow. This is the typical workflow involved in any machine learning process, any machine learning or data science role. Okay, so first is data gathering. Please understand, data doesn't come just like that. Yeah, when you learn anything, yeah, people give you the data in a CSV form, PDF form, images form, .jpeg, you got MP3, MP4. Yeah, people give you, this is the data set, please work on it. No, that's not the case in the real world scenario. You have to gather your data first. Okay, you have to understand what is my use case, what kind of data I will be requiring, and how to gather that. That's a big research methodology. You have to gather the right amount of data. What is the point in me taking or downloading the data from a HR for improve my sales? That's not gonna work. So I have to take a data which is really going to give me or help my system to analyze, study, and understand that. Okay, so data gathering is the most important thing. Okay, most of the organizations right now has got a very robust thing, like they'll give you the access to the servers and everything. You can just download the data, and it's a set of procedures that we do, and it's not very difficult, but you have to understand it's not that easy also to gather data. If I say that, can you please take all the probably you might be living in a part of a zip code where you have a lot of people who are above 60 years of age. If I just ask you, can you please get their income range? You cannot just go ahead and knock each and every door and you cannot collect it. That's not possible. At the same time, you will not understand who is going to give the real information, who is going to give a fake information. So you have to come with a kind of a methodology where you can extract, even if you have 80% of the data is fine enough, but you should have the real data which is true and which can do justice to your algorithm. Okay, that's data gathering on the first place. Then I have to, whatever data I have got, it's unstructured. I will see the age in the the gender column, the gender in the age column, and I would see the date of birth in the normal date column. It's all jumbled. I have to pre-process it, and trust me, guys, if you are allocated a work for 8 hours, and in 8 hours you are completing a work of building a model and deploying it. Okay, trust me, 50 to 60% of your time would be just gone in the pre-processing, because it's it's once you pre-process it, you have the systems, guys. You're just going to upload your data set, and the system is going to train, it's going to test, it's going to validate, and it's going to give you that answer. You're not going to do anything apart from just controlling it. But the data pre-processing, no one is going to do. Trust me, it's you have to get your hands really dirty in that. You have to understand that first. So data pre-processing, it's a really hard part. You have to take the noise, you have to take the unwanted things, whatever is not filled, whatever is filled with wrong answers, and if it is not aligned properly, you have a lot of missing values, you have a lot of things which is irrelevant. Okay, just for an example, I've told you about the flight data. Well, I just want to predict my fuel usage. I want to, as a kind of a just think that I'm the flight manager. I'm just thinking like, okay, fine, I got a lot of data. How will I go ahead and effectively utilize my fuel usage between this trip? For that prediction, I really don't need the phone numbers of the customers who have traveled. That's not the data which I need. So I have to clear off all the data which is not required as well. I have to take the data or the metadata which gives real insight to my problem statement. Okay, you can call it as a problem statement, or you can call it as an abstract, or whatever thing you want to do. And then I have to choose a model. I could be classifying something. Probably I would have got a lot of images, and I have to detect whether it is a cancerous or non-cancerous cell or anything. So either I have to classify something, or I have to find something like a kind of comparing the variables. What happens if this goes high? What happens if this goes high? Or I would be doing some kind of pattern matching, or doing some kind of prediction. I might do a lot. Okay, so I have to choose a model based on my problem statement. Then you have your data, you have your framework on your system. Now I'm going to train my model. Training the model is nothing but fitting the data or fitting the model. I'm making sure that my system is going to learn. Please learn it. At sometimes, please trust me, guys, there are algorithms and models which runs even for 2 weeks completely. It will take 2 weeks time to train the data itself. Yeah, just think that there was a kind of yeah, you might have heard about self-driving cars like Tesla. Budweiser, you might have heard about this Uber Advanced Technology group. Okay, it's ATG, Uber ATG they call it as. Uber ATG came up with a kind of a big truck for the Budweiser breweries. They were transporting kind of 6 tons of beers every day from Denver, Colorado, from somewhere in Texas. So what happens is it's about 310 or 320 miles of driving. So they made to make it automation. I don't want my drivers to spend on behind the wheels. Let them take let them do their work on collecting the inventory, making signature of all the inventories coming in up, the numbers and the timings and everything. So they came up with something which is called a completely automated one. So for that, what they did is like they took about 40,000 hours of CCTV images of the real traffic videos, because I have to make sure my truck learns the traffic rules and regulations, what it has to do when there is a green light, when there is an orange light, when there is an yellow light, or when there is a red light. What should my system do? So they came up with a lot of advanced data technology and everything, and they gave a lot of information to the system. 40,000 hours of videos, very huge, guys. It's not just CCTV images, it's video. First of all, video comes with high resolution images for that, and it's in a control environment. It took about close to 2 to 2.5 months to train the model itself. It depends on your data. Okay, it depends on your data and how to train. And then, yes, my model is trained. So what should I do now? You have to test before you go live, whether it is giving you a prediction. So after that, you have any data set that you have, we always split it into 80% for testing. I'm sorry, 80% for training and 20% for testing. 80% of the data I'll use it for training. Please learn it from 80% of what I give it to you. And after you say that you have learned, you please show what you have learned in the remaining 20% of the data. Guys, is it clear? Is it going a little bit above the head, or are you able to follow me up? Yeah. Can you please just, put it in the chat board that you're able to, whether you have some doubts, or is it going, am I going fast? Is it fine? Shall I proceed? Okay. It's good. Okay, great. It's in the right pace. Okay. Thanks. Thanks, Pringle. Okay, fine. So what I'm going to do now is 1 minute, guys. Okay, so what happened is after that, I'm going to test the model. I made sure that 80% of my data, I have got 100 data, 80% of the data I have given it to the to my system to learn it. Please learn it, and after learning it, what you have learned, I have to do the testing on you. Yeah, I got 20% of the data again. You please go ahead and test it. You please do the kind of you please go ahead and tell me what you have learned. I just want to know what you have learned to correct yourself. I cannot just go ahead and deploy it. Just understand that if that truck is not having driver, I can pause this the session. I can give you that link for the video for you to watch, guys. You can just watch it, because do you think that truck got 18 wheels? Okay, both ways it is 36 wheels. 36 wheels of truck having 12.5 tons of weight. If it is just going without a driver, do you feel comfortable driving next to the truck in your car? Definitely not. You will have a second thought. It's not a small vehicle, first of all. It's like a kind of a mini train. It's like a train. It's a huge truck in tons and tons of load without having a driver. And just think that it's hitting the highway, and you have to drive it just next to it. Any human being will have a second thought to drive just next to it. Okay, right? So I cannot take that risk. It's not that easy to take that risk. It's not a small vehicle. Just even if it gets toppled up, that's it. The highway has been closed for hours and hours of time. I can't do that. So I have to test my model. You have learned. I have given you a lot of data. Come on, you have to prove me that you have learned something. So we will test the model, and we will find out. Yeah, no systems in this world come with 100% accuracy. If you say, if someone says that my AI gives 100% accuracy, just tell them it's not possible. It's next to impossible. Okay, it's next to impossible. So you cannot do that, guys. Please do not know that. But the only thing is, like, it can exceed human accuracy. Okay, I spoke with a doctor, okay, a couple of weeks before we had a conference. They were about to identify a kind of a cancer that comes in the lower abdomen. Okay, I don't want to name the biological term. Just keep it a cancerous cell. And the doctors told me that even a very good endocrinologist, or a very good person who got 30 years of experience in scanning those kind of cancerous cell, cannot find out if that cell is less than or equal to 5 millimeter in diameter. If it is less than or equal to 5 millimeter in diameter, that's a kind of a small cancerous cells in endocrinology. Yeah, you take it as intestine. If I have that a limitation, I will not be able to find it out. No doctor or no machine will be able to find it out. But that's where the AI cracks. I'm giving 15 to 16,000 images of those scans. It could be fMRIs, it could be CT scans, it could be any electroencephalography or anything. But my system learns, and it gives 98.5% accuracy, and where the topmost surgeon or the topmost doctor in this whole world is giving me 90% accuracy. That's how, but he learned it over the period of 30 to 40 years. And my system learned it in 2-3 weeks time. That's what you get. So it is not going to replace my doctor. Never it can do a surgery. But the thing is, like, it's going to give an expert advice to my doctor to handle the operation rather than spending time on, analyzing the reports, analyzing the scan and everything. Better my doctor will spend some time on the treatment. Getting my point? That's how we do. We are giving an expert advice to the professionals. We are giving expert advice to the business people. It's not just doctors. Defense relies much on AI and data science and machine learning. I have to predict something which is going to come in the next way. Give me some insights. I'll give you my past experience. Give me some insights. I'll be equipped well to, it could be save my nation or save my people or anything. So it's just going to be, it's an expert system which is going to enhance the human living style in a more secured and more way. Okay, please understand that it's not like a kind of a social service. You are doing it absolutely a great job to this world. Okay, that's what I would say. You could be, and one more thing is, like, for you it is just data. For a patient, that's is life. But for me, it is just, I got a lot of brain images, and for me it is just data. But when you predict something, that's going to change someone's life. Just think about that. Like, we have something called a lot of cancer, which is prone to, the patient will go to the level 3 in 3 weeks time, and by the time you find the right pathologist who can do the surgery, it will take 2 to 3 months. The patient has already died. That's it. But here, I'm not going to take my reports, get back to the doctor with analyzing, and he will take another week's time. No, it's not like that. I get my report, I have a system, and my system gives 98% accuracy prediction. Yes, that's your level 1. Please start your treatment today. I saved a life there. That's how we work. And there was a business going to topple down, and they got a lot of data. So we will learn it from the experience. We will give you a real good insights. Please apply that insights in your decisions that you make in your board meeting. That will really enhance. So you are making this world a better place to live. Please don't consider to be a James Bond kind of thing. That's too far. I'm just saying, you have something called an expert system that you can only operate, that you can only understand, and from there you are sharing your insights and the results to people around you. That will make sense. That's what it is. So then, if in case, if I'm not, we cannot get 100% accuracy, that's what I'm sure. And you can get the max accuracy where the human beings cannot do that. Do you think like a doctor can and understand 15,000 images of data overnight? No, he cannot. Definitely he cannot. He'll take at least 3 to 4 months time. By the time he comes back with some insights, that would, that patient would have done. So I don't want to take the time. I'm making something, I'm just going to make something which is really in real time, give some real good results, and make some good predictions, and make something which is better. I cannot replace my doctor, I cannot replace my patient, but I can give expert advice. That's from my data. That's it. So once that is being done, I have to tune my model to get the maximum accuracy. There is a stage where you cannot cross that. Okay, that you will understand when the best way to do data science or machine learning is to do data science. The best way to learn is to do data science, and not just running. You learn everything theoretically first. Theory is more important here. You learn theoretical part everywhere, and after learning it, you deploy it, you understand that. The best way to learn is to do. That's what is here. I'll give you a data set. Please, you work on it, you come with the prediction. And when you come with the prediction, you know how to fine tune the model, how to tweak the parameters there. Okay. Fine. I'm just proceeding further. I'm just, thinking that you have understood. Okay. Types of learning. Most probably you have a lot of types of learning, but this is the 3 learning which is, quite being used among widely. Just give me a moment, guys. Okay, the first is supervised learning. Remember that you are the supervisor here. Unsupervised learning, you cannot supervise there. And reinforcement, it's a kind of a research area. You can just think about. I'm not asking you to avoid it, but just It's predominantly used for uh, playing games and just that yeah, just think about a kind of a small drone which is going to find the landmines which has been placed in some part of the world, and the defense have to they cannot do supervised there. They cannot just take a bomb in the hand and check whether it will burst or not. That risk you cannot do it. But I have an agent. I'm asking the agent, please go there, please check and learn from your mistakes. If you touch a bomb, you die. If you don't touch a bomb, and if you just detect it, you live. That's your call. So I'm asking them to learn it by itself. Your experience, you learn it. You just either you touch a water and get it clean, or you touch a fire and get it hot. So I'll give feedbacks when it touches a fire. I'll give a reward when it touches a water. That's what is reinforcement is. Supervised learning on the other way is, in this world, we got close to 50 algorithms, out of which 30, close to 30 are supervised in nature, close to 10 to 15 are unsupervised, and 5 is something like reinforcement, 5 to 10. Okay, roughly I'm giving a ballpark figure. Okay, what is supervised learning? Supervised learning is nothing but you as a supervisor, you are going to do something. You have all the rights to manage. You tell the system this is right, this is not right, and this is what you have to do. Because you know the data set, and you know what is the problem statement is. I have to amplify my sales by 10%. You have a problem statement. You know what all the parameters to do, because you are the person who did the data pre-processing. So it's been done, and after which you are taking it over there, and you as a supervisor, you are just saying, this is what has to be done, this should not be done like this, and you supervise everything. Unsupervised is, something has to be done, but you cannot identify it. Just think that you have a website, okay, and you want to understand your probably your age group, or probably the age group of the person who's clicking on your URL or a website. Or think about, you are having a kind of a big supermarket. Imagine that you own the Walmart, and you want to have a pattern of the customers that they drop in on a daily basis. What kind of customers I'm getting between 6 a.m. to 7 a.m.? Based on that, can I get some prediction? Yeah, people who have used this have used that. Okay, there was a kind of it's a kind of a funny thing, but it really worked well. I don't want to name that a department store, or it's something like you can compare with Tesco or Walmart, or a very big chain thing. What happened was, they had a finding that the male between 28 till 35 who buy a diaper pad for their kids in the evening buys beer. They were shocked. Why the hell people want to buy diapers with beers? I'm not understanding this logic. Uh, then they made it very. They what they did was, like, they collected a lot of data from their customers, in the sense, like, you cannot go ahead and ask why the hell you are getting this. No, but they have some specific procedures to get some kind of a feedback or a survey to understand what the age group of the male is. Uh, then they understand all this pattern happen only on Saturdays or on Fridays evening, only on the weekends. Okay, then they understand that these guys are between age group of 25 to 35, and they all have a kid which is just a year or 2.5 the max, and these guys are working on every weekend. They used to get some things for their kids, and also they get a pint of beer. So then you will not believe it. They moved the entire diaper section next to the beer uh, refrigerator, and that amplified the sales technically, because they don't want to take the diaper and buy everything and then go back and search for the beer and come back. If it is just standing next by next, on the same rack, it's not in the same rack though, but it's just on the next box. So from 28% of sale, It went to 34% in a week's time just because they have moved it. I don't want you to search for something which is not part of it. They moved the entire beer section just to the baby's diaper section. That's how it happened. Probably it might look weird, but that happened in the real world. That's how I get an insight. So I don't know what I'm going to do, but I have a lot of data. Let me get some insights. From the insights, let me go ahead and give something. Clear, guys? Are you able to understand what is supervised and unsupervised in reinforcement? I need an acknowledgement, please. Okay. So you have something called semi-supervised as well, which lies between supervised and unsupervised. Close to 80% of my data will be supervised. 20% of my data is unsupervised, which means that supervised learning, you have labeled data set. This is the name, this is the age, this is the salary, this is the cancer still, this is what the flight is, this is what, whether we can say it is a bomb or not, you have all the labeled ones. But in unsupervised, you don't have a labeled data set. All you have got is, the time, the date, you don't know who purchased what, you don't know what purchased whom, you don't know what made what. And you are doing a kind of a clustering. You are finding a pattern, grouping them. So every one does grouping. All the consumer behavior analytics does grouping. Do you think, like, if you log into a website and give a form, there will be 3 buckets. Just think like you're applying for a credit card. The person who is between 21 to 30 years of age with this credit score, with this earning, and with this age group goes to bucket A. And this person goes to bucket B. I can give up to $50,000 as a credit limit to the person who is in bucket A, but not to bucket B, because they don't repay well. They are having this much of difficulty. So let me just give them $20,000. So that's how they group the customers. They cannot explicitly go ahead and ask everyone who applies, please give this. Whether you cannot ask a person when applying for a loan, whether will you pay my credit card bills? No, you will. Everyone will say yes, I'll pay my bills. But end of the day, yeah, there are people who doesn't pay. So they take it from their previous experience. People who have not paid my bills are between the age group of this and this, and they are from this area and this profession. So I find a pattern. So when you apply for a credit card, yeah, guy, you belong to my pattern, which I have already identified. So I cannot give you $50,000 with this APR. I'll go with $20,000 with a very high APR. That's how it works. It takes insights. That's unsupervised learning. Okay. Reinforcement, as I said, you have an agent. You just leave it to learn it by itself. It learns. If it touches the good thing, or if it does good thing, you give a reward. If it is not doing that, you give a feedback. We don't punish anything. Okay, we machine learning engineers are kind of, we are very soft in nature. Please, take it in a very positive way. We don't punish anything or anyone. So we always give a feedback when it is wrong. We give a reward when it is right. We take it in that way. That's what reinforcement is all about. Okay. So I'm just assuming that you are clear with the types of learning here. I'll just move on to the next slide as well. So the next one, yeah, this is what I have, whatever I have explained to you, it will be here. So supervised, you have a data set, which is a training data set. It make predictions, and you are teach by example, and you as a supervisor, you are teaching that. Okay, please understand that your data set has a lot of things which has to explain about the data set. It's a labeled data set. Please understand the word labeled. Supervised learning, you have a labeled data set. Unsupervised, you don't have a labeled data set. It is unlabeled. Reinforcement, it is just an agent. You are, we call it as RL agent, reinforcement learning agent, RL agent. And that agent, yeah, I'll give you an example. Most probably everyone knows Gary Kasparov. He played with some a machine called Deep Blue from IBM or Google, and then he lost it. Okay, there is an article which is published by him. Reinforcement learning is what they have done. You cannot go ahead and teach any machine how to play chess. It's not possible. It takes millions and billions of moves. You can make billions of moves as well. It's just 32 cross 32 blocks, 64 blocks with 32 coins. Yeah, that's fine. But that 32 coins and 64 blocks can make billions and billions of moves, which you cannot explicitly go and train. So my objective is, please learn it by yourself. You play with yourself, you play with others online, and you learn it. It took some time. It took some a couple of months to learn, but once it's learned, it became genius. Gary Kasparov was a topmost chess. He's a world champion in chess. He's a Russian chess player. Okay, he practiced. Do you know something? Russians learn specific math for years and years to play chess. They prepare very well, and that guy stated that like he was not even able to play chess with Deep Blue for 5 minutes because the moves that is making is out of human reach. And yeah, as a human being, if I play chess, I'll consider a move to be offensive or defensive. I'll just predict your next 3 or 4 moves. Max, maybe Gaspro may go with 10 or 20 moves, but it's predicting your next 100,000 moves, which a normal human being cannot. Gary Kasparov is just a human being. He stated like, from 5 moves, I cannot play with this. This is something like it's very far because it learned a lot. It was trained for 3 months. In 3 months, all the 24/7, it just keeps practicing. It learned. Now I got an expert system. Now Deep Blue is challenging. No one can beat me because I have learned a lot. I have learned a lot. That's what we need. Okay, so please don't think that when people say that it's going to take jobs, it's just an expert system. We are making some expert system which is about to do it. So this is the workflow. This is the workflow that you are going to do it. Okay, the first is you have something called raw data to train. That's your data that you have downloaded, your previous experience. That is a labeled one. You have all the labels on top of it. You will call it as features or dimensions. You have its name and everything. And then you do a feature extraction. What kind of features is what I require for this kind of prediction? You take that first. And then whatever it is needed, that future extraction, this EDA, exploratory data analysis, that takes a lot of time, guys. It takes about 50 to 60% of your whole work. And after that, training the model. I have my framework, I have my TensorFlow, I have my Python, I have my system. I'm just going to train the model. And then, yeah, I have to check. It's like evaluation is nothing but, you're testing it. Generally, maybe over the period of time, you can change that 80-20 rule. You can go with 70% of your training data set and 30% with your testing. That depends over over the years of expertise. You can change that, but the thumb rule is 80-20. 80% is to train, 20% is to test. 80% I'm just going to train it, and 20% I'm going to evaluate it. And after evaluation, I know whether it is evaluating it right or not. I have to classify it first, or I'm going to predict something, or I'm going to say something. Okay, so what happens is I'm predicting something, and then I get an answer, I validate it, I increase the accuracy, I fine tune it. This is done, and after which the 100% is over. The tomorrow I'm getting a real new data set which is not been seen by my previous data. So even for that, yeah, you have a model, you would just do the feature extraction. But once this model has been built, it will stabilize. And one good thing about deep learning is it learns by itself on a daily basis. Whenever it gets, just think about, I want to predict what kind of website visitors I'm getting it. Okay, probably I have trained my model using years of data where there was not a person who was less than 10 years old. I can't say that my website will not have a visitor who is less than 10 years old. What happens if he comes tomorrow? It has to learn by itself, right? So it will learn. Once he comes, it'll identify his pattern, it will learn by itself, and it will keep it in the model. So that's how it is. So it is not just one-time training or testing. It has to learn by itself over the period of time. Okay. So we'll just move on to reinforcement. So I'm just assuming that you have understand. So yeah, this is what I have. I was just telling labeled ones, and this is what the features is. Expected salary and purchased or not. Yeah, that's my label. That's my result actually. I just want to estimate whether someone have purchased this product or not. Okay, so I have my previous example, which is a labeled one. So using this data, I'm just going to make something else. That's it. As simple as that. Okay, unsupervised learning. Yeah, probably. Yeah, there is an example when your kids are taking decisions out of their own understanding. This type of learning would be unsupervised learning. Think about a child. Okay, any human being. Did anyone go ahead and explicitly taught you how to walk? Yeah, they might have. Our parents will hold the hands and everything, but we would have fell down many times. And when driving cycle, you cannot write an algorithm to drive a cycle. You have to learn it by yourself. Probably you might have fell down a couple of times, but that's how we learned. And in unsupervised, you have a lot of data which is without any label. There is no label for me, but I have to cluster. Generally in unsupervised, there are two ways. One is clustering and one is association, which means that I'm grouping the patterns of the people who comes with the same behavior. Okay, it's like it's a kind of it's not completely self-learning, but yes, it's a kind of self-learning. Okay, so the next is reinforcement learning. Yeah, uh, what happens is, you are going to teach. I have a drone, and my drone's thing is to find a landmine which has been kept somewhere in my zone. I'm just going to tell it, please don't touch the mine, you will die. If you find it out, just inform us, we will take a call. And if you don't do that, you get killed yourself. And if you touch a fire, you will get it burnt. If you touch a water, yeah, it cleans your hand. So if you touch a water, I'll give you a reward. A reward is nothing but a prize. I'll say, yeah, thank you, and I'll praise you. And if you don't touch, and if you just go ahead and do touch the fire, I'm going to give you a feedback. Please do not touch that. Please do touch this. We don't punish anyone. That's how it is. Okay. So we'll hope you understand what is the types of learning that we have got. Okay, and this is what the measure is. All the problems in this world will come into most of these five types. Okay, most of this the five types which you have seen here. Okay, is this cancer cell or not? Is this something where I can use it or not? Okay, that's the classification. Okay, is this weird? Just for an example, we had a data set previous from a bank, a renowned bank. They did a lot of digital marketing activities, and they came up with 20,000 applications for the credit card in one single month. And they just want to know to whom to give and whom not to give. And they had a previous pattern. So they just want to find out someone who doesn't pay. They don't want to give their credit cards who doesn't want to pay. So it's called as an anomaly detection. We are finding anomalies. Okay, you have something called a firewall, and if someone is doing something, if something is absurd is happening, something which is not usual, someone from somewhere is downloading your data, your databases from your server. Something is happening anomaly. I have to find why is it happening? Why is it weird on the first place? And then how much or how many regression. I have so much of customers here. I made so much of money through the sales. So how much will I do the next month? How much will I do if yeah, I have 10 customers who gave me $10,000 as business. Today I'm having 20 customers. Can I say it as 20,000? Yeah, that's what it is. And how is this organized? Clustering algorithms, as I said, like, people who have got bread have also got butter. People who have got baby's diaper have also got beers. So that's how I do. Okay. So what should I do next? That's reinforcement. I'm playing chess. The person have moved this key. I have to move that one. So what am I going to do next? I have to learn. I may fail down many times, but over the period of time, please trust me, Every time I fell down, I'm learning. I will not stop learning. Machine learning doesn't stop learning. It keeps learning on a daily basis. It keeps learning. Please trust that. It could be any kind of algorithm. It keeps learning on a daily basis. It keeps updated by itself, or else that system will die soon if it is not updated by itself. So we are building something which is learning on a real time, just like us. Okay. Any doubt, guys? Is it fine to go? How you feel that? Is it a little bit interesting? Okay. So this is what the 5 questions, how it answers. Types of machine learning algorithms. Uh, Generally, classification and regression comes into supervised learning. Association and clustering comes in unsupervised. In reinforcement, you have something called Monte Carlo prediction and Markov decision, MDP and MMMD. Okay, so Monte Carlo prediction and Markov decision process, MDP. So in any kind of games, they use MDP most of the time. If you learn a Markov decision process, the entire reinforcement learning has been done. So that's the kind of a research level. You don't have to worry about it, but it's good to understand what is Markov decision process. If you understand MDP, Markov decision process, you'll understand reinforcement learning. And here in classification, I have set of algorithms. Okay, I have in classification, I have logistic regression, I have that linear in regression, I have linear regression, binomial regression, polynomial regression. I have a lot of things. I have support vector machines, decision tree, random forest. I have a lot of algorithms. Okay, in association, I have a priori algorithm. In clustering, I have k-means clustering, where I will find out the centroids for the k values. So it's all the name of the algorithms, and the use cases is what they have given here. The fraud detection, whether this transaction is fraud or not. You might have noticed that, guys. Please understand, I'm an Indian. Okay, yeah, I travel to US a lot. Yeah, but that doesn't mean that say about for the last 2 months I didn't use my card in India. I was in the US in a city called Salt Lake City on the last spring. I did a transaction using my Indian credit card. At the next moment, it didn't go through. Immediately, a call, an anonymous call from the bank came. Is it you, Bharat, that you're making a transaction because you never use this card in US? You are using it all the time in India. I was just thinking, yeah, okay, yeah, it's me. Yeah, you can take this is my mobile number that's been registered. If you have any questions, just let me know. I'll be happy to answer. Then after getting the verbal communication and thing, they dropped the call and they said like, yeah, you will get an automated call. Please press 1 to continue. And they said like, it just wants to make sure that I'm really the person who is my credit card in US. Got my point? So it's just learned my patterns in the previous. This person never used a card in US at all. And how come it is getting swiped in US far away from India? Then that's a really good thing. I would say that, yeah, machine learning plays an important role. Something that's not usual, and it could be a fraud. So I'm just making a double check whether that transaction is happening genuine. So after taking a clearance from me and after verifying my mobile number and everything, authenticating, that transaction went through. If I'm not the person there, then that transaction would be canceled. It will be void. Okay, that's a good thing, right? So email spam detection. Yeah, that's the normal thing. You know what a spam email is and what all the words. On a daily basis, Google collects a lot of words to detect it as a spam. You just send me an email marking, I have won $10,000 of lottery money. Congratulations. If you tell that mail, even if you send it from a personal email, the more chances it would go to the spam because of the words that you have done. And so that's how they learned it from their previous errors. Image classification. Yeah, whether I just want to identify. Yeah, as a human being, we understand what is the difference between cat and dog. You bring any cat, we can name it, right? Because from the childhood we have seen cat and dogs. But I'm training a data set which has all got German Shepherd dogs. and only all white color cats. Over the period of time, I'm giving a dog which is, yeah, say a Rottweiler or some other dog which is violent in nature. And but the system has to learn. The system has learned a different breed, and this is a totally a different breed. So how do I classify that? That's how the machine learning does. Weather forecasting, whether it will rain or not, and risk assessment, whether this person will pay his loan or not, score prediction or my stock prediction. Yes, my company is listed in New York Stock Exchange, and my thing is like my face value is $10 per hour. I just based on the economic situation, whether my stocks will go up or not tomorrow in NYSE. I'll have to find that out. Okay, so that's score prediction. Then association, market basket analysis. Yeah, as I said, you can take that example for where people who have bought this have bought that. Text mining. Yeah, this is a very good important field. You have to learn, guys, a lot. I have a lot of data which is in the form of a text. Consider that you have a lot of research articles based on something. A person from Croatia is giving 100,000 pages. Person from Sydney is publishing 10,000 pages, and person from India is doing lots of. All these are informations, and it's not definitely possible for you to download all the articles there, read it line by line, understand it. Yeah, that's it. That's way too high, man. You cannot download all the research articles. I'm just giving one simple example. You cannot understand all the things in one single day or two and understand from there. So I use machine learning. I just do. I have a lot of libraries like Beautiful Soup, Web Scrappy. I'll just download all the possible research journals which is related to that particular topic. I'll ask my system to find out the relationship between, and I'll get an insights, matter of hours, and I'll get a real good information on that. It's not only for that. You have 100 lines of email. You just want to know the date, the time, the venue, and the nature of the event. You don't want to read, nice hearing from you, thank you, all sort of stuff. I just want to know the crunch. I have to know just the info. I have to just, I don't have time to read 100 lines of email. I just need to know the lines. Yeah, you do text mining there. And face recognition, yeah, probably you might have seen immigration and the law enforcement uses a lot nowadays. You might have seen in the sci-fi movies, people matching the face with all this FBI and everything, and it pops up. Yeah, that's you can compare with that. And clustering, yeah, medical research, people having cancers or anything, and I have to find. I know my area square foot of my city. I have to plan something to reduce the traffic. How to give a better transportation facility for my people. So yeah, you can do that as well. And targeted marketing. I have a product. Um, just think about a shaving trimmer. A shaving trimmer cannot be marketed to a female. A shaving trimmer cannot be marketed to kids. It's for the adult male who is between 20, say about 18 years of age to 60 years of age. So you are going to target the product to a specific gender, a specific age group, and a specific kind of income group, because your trimmer is costing about $3,000. I'm just giving a ballpark figure, guys. So $3,000. So you have a specific use case. So you need not have to market it to first of all to females or to girls, and you don't have to do marketing to kids, because those two communities doesn't belong to get your product. At the same time, people who have fallen into your bucket, they should be affordable to pay $3,000. That's the cost of your trimmer. So you go as a targeted marketing. And as reinforcement, the gaming, robot navigation, stock trading, because you don't know what's going to happen tomorrow. Let it learn by yourself and come back to me. Yeah, this is what you have learned. Then you predict something. Okay, guys, clear? Is anyone feeling that it's too much? It's not my cup of tea, or you find it very difficult to understand the basics? Shall I proceed with the next one? Okay. Guys, if you have any doubts, please go ahead and ping me in the chat, please. Okay, it's my humble request. If you have any questions, please do not hesitate to uh, ping in the chat. Yeah, these are all couple of, you have about 50 to 60 algorithms, out of which 30 are supervised, and these are predominantly used in a lot of very it's been used widely. Linear regression is nothing but you are comparing two variables. One is independent, one is dependent. We'll talk about it, detail. Logistic regression is for classification, whether this person will pay or not. Decision tree. Decision tree is a lot of decisions which has been combined together as random forest. You have a decision, kind of think about a tree which has a lot of branches. Each and every branch takes, yeah. For example, I want to go to a place and I don't know where the place is. I'm new to that city. So the first thing is I'll ask my friend, do you know this place? He will say something. Then I understand that. Then while walking, I'll ask another person, is this the right place that I'm in? So everyone gives me a piece of information. Based on that, I take a decision. Is that right? So that's what is decision tree. Collectively, when I'm doing it, keep it, that's random forest. K nearest neighbors. KNN is also a kind of supervised learning where you make a, it's better for classification as well as for regression problems. Okay. Is any doubts? Please go ahead and ping me if you have any doubts here. Okay, let's delve a little bit deep into what is the regression is all about. Okay, I'm not going to cover everything here. I'm going to cover the overview of what the regression and how the technicality works and everything. In general English, regression means comparison of two variables. One is my dependent variable, one is my independent variable. Okay, independent, yeah, layman example is, you are a farmer, you are going to do some farming, say going to yield some crops, you're going to feed some seeds. Your independent variable is the rain. You don't have any control over the rain, do you? You don't have, right? So you can't control when you can bring the rain, or when you cannot bring the rain. That's totally independent of you. But something is dependent on you. You can take a call when to sow the seeds. As a farmer, you know that. Okay, so that's, keep it in that way. Independent variable is something which you cannot change, or you don't have control of it. Okay, I'm not going to show any demos. Maybe if you need a demo of an AI application, I'll share some videos for that, because we have some kind of time restrictions. And if you want me to run codes and give you an output, yeah, that's not possible as well. Probably in the next session we will do that. But definitely I will do that in the next session. And also regarding the videos on the AI demos, yes, I will share a video links. Which you will get it in your email shortly, probably mostly after this thing. Okay, because I want to make sure, yeah, I know, I do understand that the theory part is a little bit boring, but there is no other way. You have to understand the basics before you do something. So that's the reason. Please make sure you are very strong in the basics of understanding what the machine learning does, what are the types of learning, what are the types of algorithms. Then you get into math, then with the programming language. If your basics are strong, trust me guys, you can do wonders. But if you lose in the basics, it's really hard to do anything in the end. Okay, you have to go back and study everything in the theoretical part. Okay, so what happens here is, I'm doing a regression analysis. I'm just predicting what is good. Yeah, based on my rain, I'm going to predict whether I can yield the crops or not, something like that. So it's just a regression in simple English. It is kind of finding the relationship between the two variables. One is my dependent, one is my independent. Dependent is always your target, which we represented in Y, and independent variable is always in X. Y is equal to mx plus b. That's the linear regression equation that we use throughout our regression models. Okay, probably it might sound a little bit weird, but that's what we use. Y is equal to mx plus b, m being the slope, x being the the independent variable, b being the bias, that's my error. Y is what I have to predict. Okay, y is my independent variable, that's what I have to predict. So y is equal to mx plus b, and I draw a line which passes through all the point of my data, and I do a prediction. That's what it is. Okay, I'm just giving a very high, bird's eye view on regression. Okay, let's move on to types of. You have close to 7 to 8 types of regression. You have linear, logistic, polynomial, binomial, lasso, ridgenet, elastic. You have a lot of regression, but this three regression types are mainly used here. Okay, the first is linear regression, which has been linear regression is the very basic algorithm which every data scientist will learn to start with. It's not just machine learning or data science. Anyone who starts with the machine learning will start with the linear regression, because that gives an immense knowledge about what is exactly you're going to do. So what is the different, what is the relationship, what happens if this increases, what happens if this decreases. Yeah, it's a kind of a prediction that you do. Actually, it's a prediction. Okay. And logistic regression, as I said before, it is logistic regression could be binomial or polynomial. If you want to rate a movie between 1 to 5, that's multinomial or polynomial, you can say it in that way. But you have to find out whether it is cancer or not, whether this person will pay loan or not. You are taking a decision based on yes or no. That is a normal binomial logistic regression. When you have something like rating a movie, or how many people have rated a movie in Netflix for 4, how many people have rated the movie with 3, that's it is. Okay, polynomial regression, that's what I was talking about. When the power of the independent variable is more than 1, yeah, you go with polynomial. It all depends on your use case. When you understand your use case, your business problem case, you can understand what kind of regression you're going to do. Okay, a simple example is if you start with linear regression, we always go with Boston house pricing. Okay, that's a very good model that they have found out. Okay, and they have an issue, based on the square foot. Okay, my square foot is this. It is not just with the square foot of the house you're making the prediction. You will take a lot of variables depending on the area's crime rate, area's transportation, area's cross domestic product, the income range, and the approvals they have got, how many apartments, how many floors, how many kitchens, how many bathrooms, how many electrical things inside. Based on a lot of factors, you find the value of the price of the house. The same area of tomorrow, if I want to sell a house, if I want to buy a house, I have a model, so I can predict with this. Yeah, you predict a model for 100 1,000 square feet of house is going to for $100,000. So I have a house which is 1,550 square feet. How much it will go? I don't know, but I have a previous prediction. So with that, I can, okay, fine. We have a approved record that 1,000 square feet house is going for $100,000. He got 1,550, so it will go for $1,550,000. So that's how it is. So this is all the things that you use. Okay, I have just stated a small number of features. You have a lot of variables. We call it as variables because it is varying in numbers. Please understand what is a variable is all about. A simple example is, think about a person who is serving as a waiter in a coffee shop. He gets his salary, okay, a payday. He gets his tips early in the morning. He gets his tips in the evening also. So he gets money in various ways, in various names. It is varying values, but the person is the same, right? That is called a variable. Variable is nothing but varying numbers that is in respect with the time, with anything. Okay, we call it as variable. That's what is variable is. Variable is just the numbers or description of the future in different parts of the terms or different parts of the timing. So per capita income, accessibility to highways, distance to 5 Boston employment office, tax rate, building age, mean price, lower status, LSTAT, average number of rooms, average number of bathrooms, average number of square feet inside the built up area, the square foot area. You take a lot of things to predict that. Okay, I think like I'm giving I'm not giving too much of information, but I'm making you to understand what is all about. Okay, so Coming to the linear regression, based on the training data, I'll have to study the model, and the brain part, okay, I'm training it. I have studied, I'm training it, I'm predicting the price. Okay. I'm predicting the price. Hope this picture is a little bit very clear for you to understand. I have the training data with everything. I'm just running it into the model. The brain one is just evaluating and testing and fitting the model to my new data, and it just gives my predict the price. I have 80% of training data set, 20% of the testing data set. That's what it is. Okay, I think like, we have another 10 minutes more. This is yeah, someone have asked for the implementation, right? I can I don't want to share the codes right away, but yeah, I'll share some videos for you to see how the AI applications are being deployed in the system and everything. Okay, I just want to use the next 7 or 8 minutes for the question answers for you to before I uh, go to the next session. Whatever questions you have, please be very open. I'll be happy to explain it to you. Okay, I'm not stopping here, but I'm just giving you a pass for the next session. I don't want to run over the head. Let's take this 10 minutes to take the questions. I'm happy to take some questions for the next 10 minutes. Any questions, guys? Please be very frank, and just drop in your questions. I'll be more than happy to answer that. It should not be a one way. It's better if you type in the chat board because the voice is not that clear. Got any doubts on the how the ML is all about, and how the course will run through, and what kind of help you will be getting from us, and any doubts, please be free. Feel free to ask any kind of questions that you might have. Okay, good, Anil. How long does it take to learn DL, ML, and AI? See, it depends on person to person. First of all, I want to know the background where they come from. Just for example, I'm assuming someone doesn't have any programming knowledge. They don't have that much of strong math, and they want to come. Yeah, you can. I'm not stopping anyone to becoming a data scientist. Yeah, everyone are welcome over here. The only thing is like, I cannot specify the time limit, but usually it will take 6 months, because you cannot learn for 10 to 20 hours a day and complete it in 100 days or so. That's not possible. Yeah, we help to learn you the basics. Okay, we teach you math, we teach you Python, we teach you algorithm, we'll give you the real data set to work on it. So by the time you get a glitch of everything, a normal human being without any knowledge on programming or math would take 6 months time. And in case, if I'm very good in computers, if I'm already a software developer, that would reduce to 4 to 5 months. If I'm very good statistician, I know a very good math, then that would also come between 4 to 5 months. But if I'm starting from the scratch, it would take the complete 6 months to understand everything. Does that answers your question? If you have any specific questions, please let me know. Okay, you have to understand four things. One is statistics. Okay, you have inferential statistics and descriptive statistics, and then you have calculus. You have integral calculus and differential calculus. That's one. Calculus is used to optimize our model. Okay, we don't want to go with higher error. We want to reduce the error and increase the accuracy. That's why we use calculus, integral calculus, and differential calculus. That's the second one. The third one is predominantly linear algebra. Okay, linear algebra, you have to learn vectors, scalars, matrix, and tensors. Okay, so that's what you learn in linear algebra. And then comes the probability, uncertainty, something you are not probable whether it will happen or not. What is the probability of getting rain tomorrow? So you have to understand probability, statistics, linear algebra, and calculus. These four math concepts you have to learn. It's not a graduate or a postgraduate level. It is just a high school level math. So please don't worry. It's all about, I would say it's all 10th grade math. That's it. but that should be very strong. Please keep in mind that math you should know what is a mean, what is a median, what is a standard deviation, what is a mode, how do I have to take calculus, and what is a matrix multiplication, matrix addition, subtraction, what happens if I multiply a vector with a scalar, all sort of concepts. These concepts are not a postgraduate or a research or a bachelor level math. It's all high school grade math. Does it answer your question, Anil? That course cost, Madhavi, you have to, they will keep you posted. Smart Learning will send you an email on that. You have to get in touch with the our team here in with Smart Learning, that they will come back to you. Okay, I'll make sure. Someone from the admin team will contact you regarding the course cost and everything. It depends. Okay. Yes. Anything else? Anything else apart from the cost and the time frame? Uh, yeah. For the time being, we are going with online. Maybe in the future, we are thinking about the classrooms as well. Yeah. Online, the main advantage is you have two things. You have, you save a lot of time in traveling, and you save a lot of time in your comfortability. And the second one is like all these sessions are being recorded. Even if you miss a session, okay, for a particular day, you're not able to take a session, you will have your recordings so that you are taking it from, you can go back, take your recordings, play it, and understand that whenever you have some time, classrooms, one class gone, you cannot get it back. That's really hard. So you have some lot of pros as well as cons in online, but I would say online pros are more than cons. Oh, I am not from tech background. Can I learn data science? Of course, you can learn. The only thing is like it's not what kind of technicality we learn is math and a programming language. And anyhow, you have crossed your schooling, so you have done math, so you know what is algebra is all about. You know what is statistics, or yeah, I'm talking about the basics. So if you spend a month or so in math and the same amount of time in Python, yeah, you understand well algorithms and everything. We are there to teach you. We are there to guide you from the scratch. Then we will guide you in the capstone project and everything. So you will be having a hands-on experience there. It is accessible. I'm not getting you, Madhavi. Is it accessible for? Okay, you're talking about the videos. How difficult? How difficult or easy to learn? Uh, it's all about your interest. There are people who learns by taking a crash course for 30 days or 40 days. Okay, it depends on your interest, and I would say that please don't take it just for this, for the boom in the industry or anything. Please understand that this industry will stay for next 20 or 30 years for sure, and it will take to stabilize. The demand is very high and the supply is very less. Okay, we were looking for a candidate for NLP, and last week the number of openings were 2000, and this week it is 3000. Every week the demand is going up and the supply is getting less. Okay, to match this demand and supply, it will take 10 years. Okay, so you are in the right timing, right place, in the right zone. All you have to do is you have to equip yourself. I'm not asking you to rush up. You have some time also, so please understand that even if you take 6 months or 8 months, no, not a problem, but understand the basics and get learning. So once you're strong with the basics, yes, opportunities you have loads. In terms of difficulty level, I would say it is intermediate. It is not so difficult, it is not so easy also. It is intermediate because you will learn a lot of tools and structures and have to stitch it with each. Math is somewhere lying somewhere. Python programming language is lying somewhere. Your data set and your EDA, your framework, everything is pieces. It's all tools, but you have to stitch it everything together in your data set. So it is not easy, not it is not kind of very difficult. It is intermediate. All you have to do is show some interest, spend some time. That's it.
And
okay, yeah, please go ahead.
Kumar, as you said, math is not so difficult, right? Already algebra, these sort of things you said. But my question is, we done our studies more than 10, 15 years back. So right now again we are feel new, and I even
Uh,
background is completely social science after our 10th grade.
Okay, I understand that, but I'm not saying like, yeah, there you can do machine learning without math, but what is the point in getting an accuracy without understanding how you have achieved it? Yeah, there are a couple of, I'm not saying lots of people. To start with, what they do is, I don't want to spend some time in math. I'll spend some time in learning the data sets and Python. Yeah. After that, yeah, for example, I'm getting a result of 25.5. Unless and until I understand what is the algorithm or the math behind that, I will not be able to identify whether I have to increase it this 25.4 to 25.7 or reduce it to 24. So that intuition comes only when you understand the math behind it. I'm not saying it is very difficult. If you sit for 2 hours a day in the online classes, in a month's time, you can understand math very well. It's not like very high difficult level math. It is just a school level math. You are not going to learn anything new. You are going to brush yourself. You have learned a lot and you have forgotten it because of the time and the kind of mode you are in. You are in a different domain altogether. Yes, I do understand that, but what we do is like we refresh your math. That's it. You're not going to learn any high advanced math, kind of Albert Einstein math. No, it's not like that. We're going to learn only the school level math, and we are going to brush you up. That's it. So to my knowledge, anyone who's have completed their school studies or any basic diploma or graduate can learn this math for sure. The only thing is they should have some interest and should spend some time for that. That's it. Does it answer your question, Madhavi?
Yes, that's greatly. Thank you, Kumar.
No problem, no problem. Okay, how would you help us with assessment and project? We would give a lot of MCQs, that's multiple choice questions, and everything will come with the project. We'll give you a data set. Just for an example, I will give you a data set from the bank. These customers have paid so far. I have to make sure whether if I want to build a model, how what is the percentage of customers who will pay a loan, who will not pay a loan, to which customers I can approve the loan, which customers I should not approve the loan, which transaction is fraud, which is not fraud, which cell is cancerous, which cell is not cancerous. So I'm going to give a real data set, and then we will work on it. That's how the assessment goes. And on top of everything, you'll have a capstone project as well. Okay. Sean, is it fine? Why all concepts do we know to? Okay, see, in Python you have three stages. One is basic. Basic is about what is Python, what is the version that we are using, what is an Anaconda framework, and everything. The second level, which is intermediate level, is about loops, functions, all about file handling, input, outputs, and everything. The third is advanced, which is kind of completely into multi-threading, multi-processing, database management, and everything. You don't have to worry about advanced because that is for the core Python developer. If I'm a gamer, I have to develop a gaming environment using Python. I will go advanced level. If I'm building a website using Python, I will go advanced level. But we are not going that way. We are just learning the basics and the intermediate level functions where it is necessary to do just the coding of it. Okay. So Anil, does that answers your question? Okay. Okay, if you have, yeah, can anyone contact me with further steps of enrollment? Sean Rogers, yes, people are there. Yeah, yeah, I have just, have informed to to my team in Ismart Learning. They will contact you in the email. And regarding the fee and everything, Madhavi, you will get a call from them or from from our department through the email or call. Okay, you can rest assured you will be getting contacted with them very shortly. Okay.
Yeah, just I want to know for my future planning. Right now I may not because I'm focusing on my project, so busy with projects. So
I understand. Okay, yeah, you can see the reply. We will call or email with the batch details. Yeah, they will. You will get in touch with them, so don't worry about it.
Thank you.
You have, because since it's an online, you can have, you can choose. I know I'm not asking everyone to choose a different time zone, but there will be some time zone where you can manage. Even
Yeah.
you missed one single thing, yeah, you have a recording where you can spend some time, access it, and when you come back to the next time, yeah, I always spend some time to take questions to help you out. And only after that, it's not just me telling something and without getting any inputs from you. So you give me a lot of inputs on how to proceed, and it goes in that way. Okay, it's totally an interactive one. Yeah, Madhavi, tell me something you want.
The old students can able to join, for example, this year we are joining, and after 3 years, definitely technology advance. You are going to teaching those advanced skills. So,
Mm,
we able to join them, or are we getting the our videos or LMS is going to update with the new technologies?
yeah, LMS will be updated always, definitely.
Okay, thank you.
Okay, I think like that's all for now, and it's been a pleasure speaking to you guys. Have a great day then. See you later. Anything you just can just ping me over, ping it to the Ismart group, and they'll be able to help you out. Thanks for your time, guys. Have a great day then. Thanks for joining as well. It's my pleasure.
Well,
Bye bye.
thanks,
Take care.
Madhvi, Anil, Kumar, Sean, for spending so much of time with us, and we totally appreciate your efforts with us, and especially Kumar, that he has spent so much of time with us. Thank you, guys. Anything just keep looking into your email. We'll be sending you some more information, and then we'll get connected to you guys.